And so select only the deform mesh. Using the cloth simulation, I'm gonna put these settings here. The quality steps, I'm gonna leave this on 5 for now until we are working, but just know that after some experiments I see that it's better if you increase this to 6, but it's gonna be slower, so just temporarily leave this on 5. As a speed multiplier, I'm gonna set 5. So we have quality step 5, speed multiplier on 5. Vertex mass, I'm gonna decrease this to 0.1. If you have too much heavy vertex, everything is gonna look like a soft bag that is bouncing around. So just minimize the vertex mass. Air viscosity, drop down this to 0. I wanted this deformation body to deform and keep the position deformed like that. So I don't want gravity, I don't want any bounce back like a soft body. And this intention is what is driving my choices for these values. I'm gonna crazily increase the tension to 1500, compression and shear, increase this to 200. The bending is very dangerous. I see that this value has to stay very low, something like 0.1. Don't increase this because for my experiment everything goes crazy exploding if you increase this too much. Damping, all these three on 50. 50, 50, 50. Instead the damping for the bending, I'm gonna set this on 0. Don't confuse this with this. Activate the internal springs, and for the max creation diversion, I'm gonna drop down this to 0.01, tension on 1, compression 0.001, so that we can minimize the amount of stretching. Max tension and max compression, I'm gonna put both on something like 590, both of this. Then down here, I'm gonna expand the collision panel. For the collisions, the only thing that I want to change is to increase the impulse clamping to the maximum, which is 100. Increasing this value can fix a lot of glitches when the cloth starts to glitch and go crazy in the collision. And then I also want the self-collision activated, so that the geometry is not gonna overlap in itself. And then I'm gonna decrease the distance for the self-collision to something like 0.003. I saw that this creates less glitches. Of course, these are values with meters in the distance. They really depend on how big is your scene. So you can't take these values as absolute. Impulse clamping, again, I'm gonna put this on 100. So that we are killing the glitches in the collisions for both the self-collisions and the collision here. And now let's try to play the animation and see what happens. You can see that everything falls down, but the deformation mesh is not following the rigid body, even if it's already parented, because you need a pin group. And this is what we're gonna create right now. But before doing that, I want to set another setting for the cloth, which is down here under flight weights. I want to turn off the gravity, so that the cloth will basically bend when it collides, and then will keep that bending shape. Now, it's time to connect this cloth to the rigid body by creating a simple vertex group from here. So if you go here, I'm gonna create a new vertex group and I'm gonna call it pin. And now, we want to isolate the vision on only the deformed car body and also the rigid body car. So I'm gonna select the rigid body from here. So hold Control and I'm gonna select RB car body. Now with the mouse here, I'm gonna press numpad / and we can go inside view. Now we see only the deformed car body. Let's activate the X-ray vision and the rigid body car. The concept is to add a vertex group, which is basically you select some vertices of this and you assign to this vertex group, and that vertices are not gonna deform in any way. They're gonna be stiff. But the problem is, we want to deform this car, so we can't touch these vertices, right? And so my big idea was to create a vertex group inside the mesh. So now I'm gonna basically add more vertices inside the cloth, like separated from these vertices, but still part of the mesh of the deformation. So let's do this. With the deformed car body selected, I'm gonna press Tab to enter edit mode and ensure that the 3D cursor is in the center, also from the front, from the top. Yes, it's in the center. Now click outside in order to deselect eventual selection, and I'm gonna press Shift A, add in a mesh cube. Now, this cube is not a separated object. We can assign. If you click on Assign, now these vertices are assigned to this pin group. You can deselect, you can select them. We want to edit a little bit this internal cube. This internal part should represent more or less the shape of the rigid body, but has to be a little bit smaller compared to the rigid body, because this internal part is gonna be stiff. If it's bigger than the rigid body, it's gonna create glitches when the rigid body is gonna collide with the ground and the floor, and instead, if it's gonna be smaller than the rigid body, it's gonna be perfect. So just do this. Press Tab, enter edit mode, We want to hide all this geometry temporarily so that we can work properly without trying to go inside like this. So with this selected, I'm gonna press Ctrl I to make the inverted selection and then press H. We have just hidden the geometry. Whenever you want to see all the geometry again, just press Alt H. Right? Now I'm gonna press H. Stay in side view. First of all, click outside, just in case you have something selected. If you press A to select everything, we are just working with the internal vertices. And I'm just editing this mesh in order to be similar to the rigid body. This, you can scale it, you can extrude it, you can create more vertices. Control R here. So also from the front, we can ensure as X, we can ensure that this is representing the shape a little bit smaller like this. This face can be extruded, E to extrude, E again to extrude, S, Z, I'm gonna move it up here. So I'm gonna put this a little bit higher. Control Alt Q. Now, when you are done with this, we have to increase the geometry, because from my tests, if you have just a few vertex, the cloth is gonna struggle in order to follow the rigid body. Instead, the more vertices you have in the internal part, which is the pin group, and the better will be the thickness. So, Control R, I'm gonna scroll the mouse wheel. Don't exaggerate, just a little bit like this. Also here, Control R here. Let's see without X-ray. Control Alt Q. Just ensure that you have enough geometry all around the mesh. Maybe here. Control R, just 2 or 3. Okay. If you press A to select all these internal parts, and in the vertex groups, I'm gonna click on Assign. So now we can finally press Alt H. Let's activate the transparency. And so at the end of the game, you can see that our cloth is composed of 2 layers, the external and the internal layer, which is completely separated. But we need to do a last thing. Turn off the X-ray vision. And if you go in this arrow here, I'm gonna activate the faces orientation. The color blue indicates that the normal are facing outside, which is correct. But for the internal parts, let's hide the rigid body for now, because we don't need it. Alright, but the internal group, if it's blue like this, it's gonna create a lot of glitches in the collisions, because Blender can't understand which part is the external and which one is the internal. So what we can do is to press Tab to enter edit mode, select only the pin group, so click on select, and press Shift N, and then here in this little menu I'm gonna click on inside. We have inverted the normals, so that now everything should look like this. Blue outside, and if you slowly go inside, this internal layer should be red, and when you go inside the internal group, everything should be blue. Now you're not gonna see any glitch in the collision for the cloth. Now, we can turn off the faces orientation, we can get back the visibility of the rigid bodies, rigid body car. So, at the end of the game, we made all this process just for creating this pin group that finally we can link in the cloth options. So just go here, Physics Properties, go down until you find the Shape menu, expand it, and under Pin Group, you guess. I'm gonna choose Pin, and finally, let's turn off the X-ray vision. If you play the animation now, you should see that the cloth is following the rigid body perfectly and is sticking to it. Nice! Now, let's do stuff. We can activate the environment. I want to see the environment. Where is my environment? We still have to press numpad / on the keyboard. So now let's try to play the animation. We can, every time we don't want to see anything extra, we can click on this button, Show Overlays. Alright, you can see that the cloth simulation and the mesh of the car are following the rigid body. Now, we want this cloth to collide with the floor, with all these meshes. So to do this, I'm gonna select this mesh, collapse this, and I'm gonna activate the collision here. And in order to avoid an intersection, I'm already gonna set this on 0. Something like 150. The inner on 0.2 is very good. And it's very important that you turn off the single-sided option. I noticed that turning this off can fix a lot of intersections and glitches. Now, if you play the animation, you should finally see that the cloth is deforming and colliding with the floor, like this. And this is exactly what we are looking for. And now it's time to transfer this deformation to the car. So first thing to do, I'm gonna select the deformed car body. Go here, Object Properties, Viewport Display, Display As, I'm gonna set Bounds, so that is not very disturbing. It is still there, but is hidden. I'm gonna select the car body, not the rigid body. This mesh here, right? Under the modifiers panel, I'm gonna give to this mesh Deform. Alright, I'm gonna pick this tool here. And as an object for the deformation, I'm gonna choose the deform car body. Save the project. When you click on bind, You should wait some seconds depending on your machine. And finally, our mesh is now connected to the cloth. And yes, you should see the deformation happening. Alright, this looks good to me. I see that there are some couple of problems because some vertices are staying outside the mesh. We simply need to fix this with the sculpting part. So let's go back on frame 0. This is very important every time you do the sculpting in frame 0. So we need to fix some vertices here. First of all, select the car and click on Unbind. And then select the deform car body, which is this one here. And I actually gonna isolate the deform and the car. So these two meshes, I'm gonna press numpad/. Alright. Select the deform mesh, go on sculpt mode. Alright, we need to see the actual geometry, so I'm gonna go here, object data properties, display as solid. Alright, I remember that there was a little dot, so just carefully set for it. There we go. We can inflate it. When it's done, go back to object mode, set this back to display as wire, and then select the car and remember every time to rebind it. So in the modifier, click on bind. And we can actually set the deform mesh on bounce. Alright, press numpad/. This is what we get at the end. For now, we just need to create the entire setup for the station, connecting all the rigid bodies for the wheels and the doors. So just don't worry for the fact that it is looking a little bit soft. You need to tweak all the settings for the clothes later. Doors. Select this door here. So I'm gonna rename this door L. That stays for door left. Pressing numpad/. Shift S, cursor to selected. Select the collection of the rigid body. And then Shift A, mesh cube. And this cube is gonna be called RB, rigid body. Door L, rigid body for the door in the left. Alright, it must be, as always, as much low poly as possible. Now adjust this mesh until it somehow covers the door. This rigid body has to be smaller compared to the actual door. I'm gonna leave a lot of space around, maybe here, because I want a collision to deform this part. So edit mode and go on modifying this mesh. Alright, now I got my rigid body for the door. I'm gonna press Ctrl A, apply scale. You must ensure that this rigid body is not intersecting the rigid body of the car. And as you can see, we have a little bit of intersection here. So, edit mode, select these faces and push them a little bit on the right. It's also convenient to leave a little bit of space in between, like this. Alright, now for this mesh, I'm gonna activate the rigid body. I'm gonna set a mass of, I don't know, 30 kilograms. Convex hull in this case is good because this is a convex mesh. I'm gonna increase the friction, something like this. I want to push down the damping translation to 0.008. And also I want to put down the rotation on 0. I'm gonna select the door and then the rigid body door. And then I'm gonna press Ctrl P, parent to object. The door is now following our rigid body for the door. Go in the object properties and down here, display as wire. Also, we can set this to be visible in front. Now, let's create the deformation mesh. Select again the door, Shift S, cursor to selected. I'm gonna select the collection of the deform meshes. Shift A, add in a cube. So scale, rotate, until it somehow covers the entire door. When you are done creating the shape, Ctrl A, apply scale. As always, let's subdivide this a little bit. Ctrl R, add more vertices. Ctrl R, scroll mouse wheel, and also here, just a little bit. Maybe 3 like this. Alright. I'm gonna go in the modifier panel, add the modifier, shrink wrap. As a target, I'm gonna choose the door. So first, find the door. There we go. So as a target, let's choose this tool here. I'm gonna pick the door left. There we go. We can offset a little bit in order to push this a little bit outside. And again, I'm gonna apply the remesh modifier, without exaggerating with the geometry. So try to increase the voxel size to something like this. But I want to push more outside the shrink wrap, something like this. Alright, and a little bit smaller the voxels. We don't need very much a high amount of geometry for the door. So just tweak these options for the shrink wrap and the remesh until you find that the mesh is fine. So something like this to me it looks good. So let's apply all the modifiers. With the mouse here, Ctrl A. With the mouse here again, Ctrl A. In case you have too many vertices, in this case, for this door, enter edit mode to make the count. Select all of them, and you can see down here, 1422 vertices. To me, for just a door, they are too many. And so I'm gonna do this. In the modifier, I'm gonna apply a decimate modifier and just decrease this. And you can see that the face count has dropped down to 800. So let's try to go down a little bit more. I think this is fine. Let's try to apply. enter edit mode. Yes, it's a little bit messy, but I think it can work. Right click, shade smooth. In case you have uncovered parts, you know what to do. Go in sculpt mode, inflate tool, F button to increase or decrease the size of the paint tool, and cover those parts. And let's go back to object mode. Alright, now edit mode, select all the faces, pressing A and Shift N to fix the normal. Alright, and now we need to create the internal vertex group for the pin group, which is a little bit tricky because this door is kinda almost flat. So, enter edit mode. I'm gonna click outside in order to deselect, and then Shift A, add in a cube. Pay attention that we have added this cube while we were in edit mode, not in object mode. We are just adding vertices, so just work on this cube until it stays inside the door. We can also activate the X-ray vision, Ctrl Alt Q. I'm trying to represent more or less the shape of the rigid body again. Scale it, move it, and rotate this, and put it inside. This internal group doesn't have to be very flat, otherwise the cloth simulation is gonna behave in a weird way. Then we can hide the other polygons, so Ctrl I and press H. We have temporarily hidden all the polygons that are not the internal parts. Now, alright. Now we got the internal group for the cloth simulation, but it doesn't have enough vertices and edges. Ctrl R to edge loop and slide, scroll your mouse wheel. Ctrl R again to add more geometry like this, maybe more here. Now I'm gonna press A to select all the visible geometry, and I'm gonna go here under Object Data Properties. I'm gonna click on this plus button to create a new group. I'm gonna call this pin and assign. Now with the mouse here, I'm gonna go in face mode. I'm gonna press Shift N, and if you activate the face orientation from here, you can see if you are doing it correctly. Yeah, also we have to turn off the X-ray vision. We have pressed Shift N, and there is this menu in the left down here. You can activate inside. So these faces has to be read outside, right? And now, if you press Alt H, we have completed the mesh for the cloth simulation. I think that some faces are staying outside, and push them inside. If you select the first face here, and then holding Ctrl Shift and left click on this face here, GX, you can easily push this face like this. I'm gonna call this deform door L, because this is the door left, and then I want to isolate only this object, so press numpad / and then press it again, so that we have isolated. Let's check the face's orientation. So outside is blue, when you get inside is red, when you get inside the internal vertex group, everything is blue again. So this is perfect. You can see if your pin group is correctly saved. Just click on select, and you can see that we have a nice internal group for the pin group. Now, numpad / turn off the X-ray, turn off also the faces orientation. Now select first the deform door left, and then holding Ctrl, select the rigid body door left, and then with the mouse here press Ctrl P, set parent to object, so that this deform mesh will follow the rigid body. And then basically for the cloth simulation, we can simply apply all the same settings that we used for this mesh here. So I'm simply gonna activate the cloth simulation for this deform door, physics properties, cloth simulations, speed multiplier on 5. Now, the difference is here. Just for the doors, because they are so flat, I want to activate a little bit, just a little bit of pressure that I noticed that were very helpful to prevent the door to become flat during the collisions and stuff. So just a little bit of pressure, like 1, is more than good. Also for the fluid density I'm gonna set -1, just a little bit like this. And under shape I'm gonna choose my pin group. Collisions, all the same settings, so impulse clamping 100, self collisions, distance 0.003, impulse clamping again on 100. Also I'm gonna drop down the gravity to 0. Under object properties, display as bounds, so that we can finally see our door. Select the door and give to this door a mesh deform modifier. Take the pick tool, because I'm gonna choose the object for the mesh deform, and I'm gonna choose the deform door L. You can see it here and bind. Now turn off the overlays. Okay, the door is deforming and is following, and now we need to connect it to the car. We need a simple constraint, something around in the middle of here, between the door and the car. So to do this, shift right click here in order to put the 3D cursor, and then here I'm gonna add a new collection because we are starting to add constraints. So the name for this collection is gonna be constraints. With this collection selected, I'm gonna press Shift A, add in an empty, single arrow, press S to scale it. I want the constraint to be very big so that we can easily see them every time we need to tweak them a little bit. Control A, apply scale. Try to place this constraint in the line of the door, like here. Something like here. So we can move it a little bit outside from the top view. Something like here, I think. And we can eventually rotate a little bit this constraint like this, just a little bit. Alright, Control Alt Q. Now I'm gonna go in the Fiji properties, and for this empty, I'm gonna activate rigid body constraints. As a type for this constraint, I'm gonna choose hinge. Hinge is the perfect constraint for a door. After many tests, I see that overriding the iterations can avoid a lot of problems, so override iteration and set it on 300. For all the constraints that we are gonna create, I'm gonna increase the override iteration to 300, alright? So, this constraint, we're gonna choose two objects to connect. That must be rigid bodies. So let's find the collection of the rigid bodies, and then, as a first object, can be the car body RB, rigid body, and as a second, the rigid body door left. And ensure that you select the rigid bodies, not the object, alright? They must be object with physics. If you play the animation, stay connected to the car, but is rotating like everywhere, and also is not colliding with the car. So, we need to do two things. First, with this constraint selected, I'm gonna turn off disable collisions, and then activate the Z angle, so that we can limit the rotation of the door. When you activate the Z angle, you don't probably see this blue graphic here. And that's why I want to suggest you to download this addon, which is Visual Limits. It's a free addon. I give you the link in the description so that you can easily download it. Visual Limits is a very useful addon that lets you to actually see the graphic representation of the angles when you play with the limits and stuff. When you get this page, go to Code, download zip. When you download the zip, just don't unzip it. Just go on Blender and Edit, Preferences, Addons, and click on Install, find your zip file, and just install it like that. And then you click on Save Preferences. Okay, one thing about this graphics representation is that they don't represent actually the angle of the rotation. But at least you can have an idea if the constraint is rotating in this axis or in this axis. That for a door doesn't make sense. So, once you get this addon, just play with these settings of the angular limit and play and replay the animation until you see that you get it right. Alright, after some tests I found out that the right values were actually 0 here and 90 here. So now the door is opening correctly and is stopping the rotation after some angle. Two things to notice, from now on, because we are starting to have many things into the caching, every time you change the values here, you will see some glitches like stretching and stuff like that. This is a common cache problem. So from now on, you will see myself to do this. In order to force the cache to reset, before playing the animation, select the ground and press Tab, and then press Tab again. This will force the cache to reset. When you are changing cloth settings from now on, or some constraint setting, everything that regards physics, in order to update the physics simulation, select one of these ground and then Tab and Tab again. And then you can play properly the animation. Annoying Blender things. Now this is working properly. You can see the nice deformation happening in the door. Another thing is that you can see that when the door opens, there is actually nothing in the middle, in between the door and the car. If you want, you can simply create some simple objects like a cube extruded many times that can look like something connected to the car. And then you don't need to deform that part. You simply create these two objects and parent these two little objects to the rigid body of the door, so that they will follow the rotation of the door, alright? I'm not gonna do it now anyway. So, for now we got this, which to me is looking fine. So we got the door left, we got the deform mesh for the door, and the rigid body of the door. Now the same steps that we followed for the door, you can repeat the same process for the hood, and for the back door here, and for the other door, right? Alright, I just finished to set up the same steps for this door, for this hood, and also for this back door. All of them already have now the deformable mesh, the rigid body, and the relative constraints. The only difference is in the rotation of the constraint, because this is rotated by 90 degrees compared to this one. And also you may probably have to tweak the rotation in the constraint. And now I want you to pay attention in this thing. Select the rigid body collection and right click and click on visibility, isolate. Now we are watching only at the rigid bodies that compose this car. Let's select one of them and then all the others. Then let's see them better. Let's go here and holding Alt, I'm gonna click on Display As, Solid. Alright, these are the rigid body. So this ugly thing is what is driving the physics simulation with collision and stuff. As you can see, they are more or less cubes with a very low poly count. Just a couple of faces extruded. And your rigid body should look like this, but the most important thing is that, as you can see, they don't have to intersect. There is a lot of space in between here, also in between here, also between the door and the car. There is nothing that is intersecting. Otherwise, this will create a lot of problem and exploding parts during the simulation. Now, let's select them all again, and holding Alt, I'm gonna click on Display As Wire, and finally we can get back the visibility of everything. So rigid bodies collection, right click, visibility, isolate again. So I want to see how it's looking right now in the animation, but before playing the animation, as I said, I select this, press tab again, and now we can finally properly play the animation and see what's going on. As you can see, everything is playing correctly, correct rotations, and so we are done with the deformable parts. And now it's time to think about all these objects that will not be deformable. And that's why it's gonna be much easier.